All right, some centripetal acceleration problems. Circular motion in general. So on this worksheet, number 1, a race car makes 1 lap around a track of radius 50 meters in 9 seconds. What is the average velocity? So remember, average velocity, total distance and total time. Total distance divided by total time. In here, 50 meters in 9 seconds. And so it's going to be 5 5/9. Or approximately 5 point, what is it, 5? Yeah. Meters per second. Okay, and then what was the car's centripetal acceleration? Centripetal acceleration in one formulation is v squared over r. The radius is 50. Whoops, okay. It's late, I'm tired, fail. I got to do in the next part. NASA, okay. As you might have caught, total distance is circumference. So in this case, circumference over time. And so 2 pi times 50 over 9 there. And that will always happen. You gotta learn, you make a mistake on the test and you gotta be processing like that, because we do things automatically sometimes. But then think about what you're doing, process it, see if it's correct. Don't just take your answer as given or see whatever calculator says. You could have punched buttons wrong or all kinds of things. You need to be thinking about the general context and if an answer makes sense, if we can reason it out in a different way, things like that. Because while in some math classes you might do some problem in isolation, in the real world things are always connected to each other. You need to make sure something's correct in different ways. Otherwise, it's not really a problem's wrong. It's like money lost, someone can get hurt, you can get fired, get in trouble. So train yourself to think about it, please. So then we got 100 pi, 100 pi divided by 9. Okay, so about 34.9. Because once I got to doing the other one with centripetal acceleration, I was trying to figure out what the radius was, and oh, 50 was the radius. So back to this. V squared over r. And so we have 34.9. I'll make it 35. Radius is 50. So about 35 squared. $24.5. Cool. Meters per second squared. All right, there's the first one. Number 2. On this worksheet, I'll put a link in the description field so you can look at them. So a piece of string is 1.5 meters long. A ball makes 120 turns each minute. What's the average velocity of the ball? So one thing we can do is think 120 turns a minute. That's 2 every second, because 60 seconds in a minute. Okay, so we got to have 2 of these, 2 turns every second to make 120 total turns in a minute. That means 1 turn every half second. And so total time, total distance, it's going to be something over half a second. The 2 pi r, 1.5. I remember this time, of course. Don't need that, just 0.5, don't need the second mark. So 3 pi divided by 0.5 or multiplied by 2, about 18.8. meters per second. And then centripetal acceleration, you know, v squared over r again. Whatever that is. And then we could do yeah, I guess another thing kind of is to get the average velocity. We could also have done period and frequency are inversely related. So we'd have 1 over 120. That'd be a minute though. I guess I'd rather just do it the way I did. 1/120th of a minute, and that still gives you half a second. So 1 per half a second. Do the formula and think about period and frequency, or just think about it the way I did. Either way. Number 3, pretty straightforward. You get speed and radius, v squared over r. And 4, you just got to figure out how fast something's going. It's 4 meters long. You got 2 pi r. How long does it take the minute hand to go around? Think about that yourself. Then you can get the speed, and then do v squared over r. The 5, kind of same thing in a different way. A period of 1.8 seconds, it means it goes around once in 1.8 seconds. And so you just do 2 pi 15 over 1.8 and get your answer. So pretty straightforward after this. Maybe I'll do 1 or 2 more, but answers are at the end. So number 9, a 2 kilogram object is tied to the end of a cord and whirled in a horizontal circle of radius 4 meters, completing 2 revolutions in 6 seconds. So 2 revolutions in 6 seconds just means 1 revolution in 3 seconds. Simple proportion. So in 3 seconds, it goes full circle. That's the idea. Circumference of a circle is 2 pi r. So full circle in 3 seconds. So 2 pi times 4 over 3, and that's your answer. So there's some basics of circular motion.